So 10.2. We are factoring trinomials of the form x squared plus bx plus c. All right, don't panic. It's really not that bad. It's just kind of time consuming in a way. And even then, y'all have done much worse. Okay, so let's talk just a refresher course from yesterday. I'm going to put 10.1. This is from yesterday. You're writing this down. Remember, yesterday we had 36 x squared. Hold on. Okay, because of that interruption, we don't need to see that. All right, y'all remember yesterday. Let's move on. Okay, so what we're going to do today, what we're doing today, we are factoring. What this means, whatever, x squared plus bx plus c is opposite of FOIL. Remember FOIL. FOIL, if you remember, we had this, right? And it was, the first, you multiply, the outside you multiply, y'all remember this, inside, and then the last two we multiplied. Remember that? From last chapter, right? Okay. So we're doing the opposite. We're doing the opposite. Where last chapter they gave us this and we had to figure it out. Today they're giving us this and we have to figure this out. Let me show you. Step 1. Write factors of the first term. That's step 1. Write factors of the first term. And I'm going to give you lots of examples. Step 2. Find factors of last term. Whose sum, what does sum mean?
Addition.
Adding. Adding. Sum means adding. Whose sum is second term. I know. This sounds very confusing, but you'll get it as soon as I start doing it. So, you're going to write the factors of the first term. Then you're going to find factors of the last term whose sum, when you add them together, equals the second term. And then you check by FOIL. Now, when they say find all the factors, that's the part that is annoying. Because you have to find all these different combinations of factors. And it's a long list for some of the stuff. For some of the smaller, problems at the very beginning, the list isn't as long. But wait till you see my first example. It's annoying to find the one combination that works. So I'm going to wait till everyone has this down. If there is no solution, then it's prime. If there's no solution, then it's prime. I'm going to tell you something. There is nothing more annoying than listing all the combination of factors and doing all that work to find out it's prime. You have a question?
Yes. Excel, I wrote prime and said it was wrong.
Yes.
And
You put prime down?
Yeah.
And what did it say?
Said it was wrong.
What was the answer? It was just 1?
Yeah.
You don't remember? Is that what it said on yours? Instead of prime?
Yeah.
Huh. That's interesting. Well, then go with that. If it's prime, then I guess if they want you to put 1, then just put 1. You know, everything I've always heard is prime. Your book says prime, but if IXL's different, then go along with what they do.
We probably don't want them to like write words in that.
Could be, because prime, relatively prime and 1, pretty much kind of the same. But, so just go ahead and put 1.
If you write that on a test, would that become wrong?
If you put 1 instead of prime, probably not. Okay, let's move on. That's a good question. I've always had these same IXLs assigned, and no one has ever said anything. I guess, I don't know.
Maybe they figured it out.
Yeah, they might have just gone with the flow and never said anything to me. It's good to know. All right, page 411, examples. Let's jump into examples.
What is each thing? Does it say like a half page to get each one? Is each one like very long?
Oh, you're going to need some space.
Like this much?
Yeah, that's probably fine. All right, is everyone there?
No. There you go.
Are you there? Okay. Are we there back there? All right. Let's look at number 1. Something you need to know, I'm going to put this right here, this is a star. Write in what? Descending order first. You know, like we always do. So I just want to remind you, make sure you write these in descending order first. Okay. Number 1. A squared plus 8a plus 15. Okay, the directions say factor. If the trinomial will not factor, write prime. So for this, we're going to follow directions. So we are going to factor. We're doing the backwards FOIL. This is what we want our answer to look like. The 2 parentheses. This is our goal. Okay, so we're going to factor out stuff. Now, if you remember yesterday, we would find something that all 3 terms had in common, right? Take that out, and then the rest we kept in the parentheses. Well, we don't have anything in common. That's where the FOIL comes into play. So, notice this is our first term. This is our last term. Okay, this is our second term. I'm going to put an S. Remember up here, write the factors of the first term. Here's our first term. Find the factors of the last term whose sum is the second term. So, this one's easy. What are the factors of a squared? A times what? A times A. Can there be anything else besides A times A? No. So because of that, we can go ahead and put A and A here. Remember, we're doing FOIL. So if you remember, first, bless you, A times A is a squared. Do y'all see where I got that? Okay, now we're looking at the last term. So over here, we're going to list, I put an L for last, all of the different ways, guys. Are y'all listening? Right here, we're going to list all the different ways that we can get positive 15 when we multiply, but a positive 8 when we add. Now, I know this is easy. Some of y'all have already figured it out. But guys, let me show you what you're going to end up having to do. We can do 5 times 3 equals 15. When added, what do we get? So I'm going to put that over here. But we can also switch it around to 3 times 5 equals 15. If we add it, what do we get?
8.
8. Guys, this is just the beginning. I know you're like, well, that's the same thing. You're right. It doesn't really matter in a problem like this, but guys, guess what's coming? Position of the 5 and the 3 will matter. What about 1 times 15? Is that also considered factors of 15? Yes, because 1 times 15 is 15, so that works. But if we add them, what do we get?
16.
16. So that's not going to work. What about 15 times 1? That gives us 15, but again, it gives us 16, so that won't work. We can also do, boys and girls, and you are writing this down, -5 times -3. If we multiply those together, what do we get?
Positive 15.
So that would work there, but if I add them, what do I get?
-8.
Thank you, Franz. So does that work?
No.
And then we can do -3 times -5. It also gives us a positive 15, but a -8. We can do -1 times -15.
No.
That gives us a positive 15, so that checks.
No,
But if we,
16.
that's right, if we add it, we get -16. We can also do -15 times -1, and that too gives us -16, so those won't work. Guys, guess what? You need to write all this down. I will be looking at your notes today. You better have all this written down. The reason why I'm starting you off now with this is the obvious answer, and I get it, but I'm getting you ready for what's coming. And it's going to be ugly. You're going to have all kinds of different ways to figure it out. So we know right now that this, either one of those would work. And in this case, it doesn't matter. We can either have 5 here and 3 here, or 3 here and 5 here. I'm going to go with the first one. I'm going to put 5 here, and that's a positive 5 and a positive 3. Now, that should work.
And then you just do 4.
And now you just check with FOIL.
Oh, so that's the answer?
We think, but let's check. A times A is
A squared.
A squared. A times 3 is 3A. 5 times A, 5A. I'll let y'all catch up. And then 5 times 3 is. Now, we combine our like terms. Here's our like terms. A squared plus 8A plus 15. Oh, look. It checks. It's the same thing. So this is my answer. So I'm going to let y'all catch up. Write that down. And that's what we're doing today. But this problem, it's number 1, y'all. The first couple problems are always the easiest, right? And then they start getting harder and harder and harder to where you start really getting annoyed. So I don't even know if it's going to be today or tomorrow's work or whatever. These right here are going to help you out. I'll have kids, seriously, and I can't remember if it's today's work or tomorrow's work, but anyway, they'll sit there and have all this down and still can't find which 2 are going to work. It gets tricky. And then they'll realize they missed one. So keep in mind, even these negatives later on are probably, going to be coming into play. So it could be one's negative, one's positive, etc. You don't know. You're just going to have to keep playing around with all the factors and different combinations and placements until you figure it out. Any questions so far? All right. Let's do another. Three. A squared minus 4a plus 3. All right, don't forget our goal is to have it, we're factoring it to make it look like that. Backwards FOIL. Keith, can you see around that thing on her head? Okay, good. Okay, so this is nice when all you have is one letter, and it's squared, and you don't have, because you're going to have some with a little number here, and that's no fun, because then you have to start doing that all that factoring for the first one too. But as long as it's just one letter and it's squared, we know already exactly what's going to go in that place. Enjoy these while they last.
Enjoy all these, because these are all one letter.
Exactly. So here's our first, our last, and our second. Now we're going to focus on all the combination factors to get 3, but also when adding, get us a -4. All right, so don't forget we're doing FOIL. We're looking for the last one that when added gives us -4. So what are some ways to get a +3? What two numbers can we multiply? Someone besides Franz all the time. New? Gives me 3. When we add, what do we get? Okay, so it works for the 3, but it's not working for my second one. Shh. Keep in mind, you can switch them up, but we get the same thing, and that won't work. Franz, you're about to die over here. So what combination can work possibly?
-3 times -1 would be positive.
And
-4.
-4. And then we can also switch it. -1 times -3 equals a +3 and a -4. So there you go. There's my negatives. That satisfies getting the last digit as a +3 and the second one as a -4. We could use either one of these. I'm just going to use the first one. I'm going to put -3 here and -1 here. So then all we need to do is check now. So I do my FOIL. A times A is good. A times -1. Okay. -3 times A. And then -3 times -1. -3 times,
3.
There you go. So then I combine my like terms, and I get a squared minus 4a plus 3. And I look up here at the original one, they check, so therefore this is our answer. Not, you don't have to put all the arrows or anything, but that's
that
it.
was way shorter than the other one.
Right? Any questions so far?
Yeah.
You are doing great. I'll let y'all catch up, and then we'll go on to the next one.
Number 5.
We're going to do number 5. Does everyone have number 3 down? Y'all got number 3? All right. Sophia, did you get number 3? All right. Number 5. B squared plus B minus 20. All right, this is a little different. What our second number here, what is it?
Oh,
If we don't have a number here, what do we pretend is there? I'll put a little 1 here just in case. So we're looking for combinations of factors. When multiplied, we get negative 20, but when added, we only get 1. So our goal, it's like solving mysteries or puzzles. We know because there's only a b here, a b squared, that b is going to be our first term. Over here, I'm going to start listing all of my, oops, I forgot to put this. I just put that to remind us. So all the ways to get negative 20. So let's see, Valeria, what's one way to get negative 20? Times positive 2. That gives us negative 20. But if we add it, we get negative 8. We could also say positive 2, negative 10 over here, still going to get us the same thing. So these won't work. Okay, let's see. Ariel. Okay, that would give us a negative 20. If we added them, we would get negative 1. Well, that satisfies a negative 20, but oh, look, that's a positive 1. So even if we switched these around, we would still get a negative 1. So that won't work. Franz?
Positive 5 times negative 4.
And that gives a negative 20, which works. If we add it, we get a positive 1. So there's our winner. But please know that, like up here, I could have done negative 2 times positive 10. That would have given me a negative 20, added it a positive 8. Do you see all the different combinations you can do? You could have even done like negative 20 times positive 1. But that still wouldn't work. But you see where I'm going with how all the different combinations that you may have to go through to get the right one. That's what's annoying. And then you're sitting here trying to find all these to find out it's prime. I'm telling you, you will get mad. And I typically do not put those on the test because I don't want my students wasting their time going through every single situation to find out it's prime, or sit there and say, oh, I can't find anything that works, it must be prime, when really they just hadn't gone through all the factors. You see what I'm saying? So on tests and quizzes, I do not put any prime ones. Pete, are you taking notes? Okay. All right. So positive 5 and negative 4. Nah, it really doesn't. So we check. B times B is B squared. B times negative 4 is negative 4B. I have 5B. And negative 20. Combine my like terms. And I have B squared plus, you can say 1B or just B, minus 20. And they match. So, huh? When will you? Algebra 2. You will definitely see this Algebra 2. Probably pre-cal. Oh yeah, you're going to see this stuff again. Okay. Let's see here. I want to show you number 9. Oh, a lot. Does everyone have this?
Take 2 to
No. All right, I want to show you a prime one. X squared plus 7x plus 4. Again, we're supposed to get, that result. If you look at all the factors to get 4, at no time when adding can you get a 7. 2 times 2 will give you 4, but when added, gives you 4. We could do 4 times 1, same thing. You can even go through the negatives. -2 times, it's the same thing. At no combination can we get 7. You can try all of them, but you'll never get it.
maybe decimal, but
So then this would be prime.
maybe in decimal, but
Yeah, but
it's no decimal.
y'all see what I'm talking about as far as prime goes? All right. I'll wait till you have this down. A number one. In the first one. Yeah. I'm going to. Let's see the fact. Really, they only have a couple for you. They don't really have that many. Okay, so let's do, because I think y'all got this. I'm going to do 1, 2, I'm going to do 3 more. Yeah, I'll do 3 more. All right, number 11. I have x squared minus 9x plus 20. Okay, we're looking to have it look like that. We do know that x is going to go in the first. I'm going to let y'all list on your own all the factors. Then raise your hand when you have figured it out. Ariel?
Would it be -4 times -5 equals +20, and then if you add it, it would be -9?
Okay, so -4 times -5 would be +20, which satisfies that one. And then if you add them, you get -9. So that would work. -4 and -5. So then we check x, good job, x squared -5x -4x, and then +20. Combine all the like terms. X squared minus 9x plus 20. And it checks. It may take you a while to figure out the factors that work, but all those different combinations. Okay, y'all ready to do a little? I'm going to do 2 more. Oh yeah, and this is a good one. Y'all have this down? All right, 23. 23 is 56 plus 18x plus x squared. Keith, can I have it look like that? No, Keith, what do I do? Where do I move it to? And then what do I do? What goes next?
I got, 18x.
There you go. You're so smart, Keith. All right, 2 parentheses. We know already that x is going to go here. So backtrack. Notice he put these in descending order. Make sure you do that. Descending order. All right? All right. Okay. I said all right. Okay. So now you have to find all the combinations of numbers that will get you 56. But when added, gets you 18. Oh, and there's a lot. I'm going to wait and see who finds it. Keith, I bet you're going to find it. Because you're just so smart. I know you've got this.
Stop staring at me.
I'm waiting for an answer. I have it in my head, and I'm like trying to send it to your head.
It's not working.
Okay. Sorry. See, everyone thinks it's going to be something with 7 and 8. Wrong. You okay? All right. You want to pass?
Yes.
Chat.
Negative 14.
So you think negative 14 times negative 4, well, which is it? Because that's going to give me a positive 56. But if we added it, it'd give us a negative 18. Oh, no. So what is it?
Positive 14 times positive 4.
That would give us a positive 56. If we add it, it gives us a positive 18. How many of y'all were like, man, I didn't even know about 14 and 4?
I'm just going down the line of 18 and slowly going down.
Yeah. So if you look, this was last year's. We started writing a lot of it out. 7 and 8, 8 and 7, 56 and 1, blah, 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 28 and 2, 2 and 28. Trial and error part. That's what I was talking about. You may be listing a whole bunch. Some of y'all might even stop here and say, oh, well, I think this is everything. It's got to be prime. And then I'm like, yeah, no, you forgot some. What? I mean, so that's what I'm saying. You can't forget any. It's a pain, I'm telling you. So, yes, 14 and 4 or 4 and 14. Doesn't matter. And I'm just going to tell you, if you check, it's right. Okay, so for time, I'm just going to let you know that.
What time is it?
It doesn't matter what time it is, Bronze. It's still early. All right. Does anyone have any questions? No? Okay, here we go. Y'all ready for the big ugly? 20. Oh, don't say that. 27 is really not ugly. I'm just joking. Okay, so new requested one that looked different. She's got to be different. And actually, I had already planned on doing a different one. 3x squared. She wants to be challenged. She didn't want surprises, y'all. That's really what this is all about. She didn't want to get something and say, you didn't teach us that. Okay, see? 3x squared minus 24x minus 27. Oh, no, Sophia. What do you notice that's different? Oh, my gosh. The first one has a number. Oh, no. Because those were easier when they didn't have a number. But what do we do now? You mean show you what you do? We do yesterday's work. What do all 3 of these terms have in common? Yes, Morgan, there's a number in each one. New, what did you say? See, the cone on your head is affecting your brain. Yes, 3. All 3 terms have the number 3 in common. This is like yesterday. So I'm going to pull out that 3. Do they all have an X in common? No, but they could. In some of the more, difficult ones, there could be some letters too. So you do what we did yesterday. You pull out what they have in common and then leave what is left over. So here I'd have x squared. Chap, what would I have here?
8x.
Very good, because negative 24x divided by 3 is in fact negative 8x. And then Valeria, what is negative 27 divided by 3? Yes, ma'am, negative 9. Yes. You know what we do now? Pretend that 3 is not there right now, and we do what we've been doing up here. See, now we have a nice little trinomial that we can work with. Do y'all see that? So look how I'm writing it, because you know what a common mistake for my students? This 3. They took it out, but then it's like they trash it. It's gone. They just forget about it, and you can't do that. You got to bring that 3 down and then do your 2 parentheses. Don't leave off the 3. The 3 has to be there or it's wrong. So now I got my X and my X. Raise your hand if you can tell me what goes here. That when multiplied, give me negative 9, but when added, give me negative 8. Oh, Keith has the answer.
X plus 1 times x minus 9.
Okay, so he's saying 1 times negative 9 is going to give negative 9. That works for the last one. If you add them together, you get negative 8, which works for the second one. Very good. So that's a positive 1 and a negative 9. And it works. You can go back, do FOIL on this. For time, I'm just going to tell you it worked. And then multiply the whole thing by 3. So you're going backwards. And this is your answer. Are there any questions about today's work? I think I hit on all the what ifs and the problems with IXL and everything else. What? Right here? Yeah, I guess if we had something like this. Yeah, absolutely.
So then just be x, y, as well.
Yep. Then I don't know. Yeah, it would be prime. Let's just go with that. All right, so 411 to 412. When you get to a problem like that, call me up, New. All right, so you're doing page 411 to 412. Numbers, stop whispering and being loud and everything else. Okay, you're doing.
13.
Shh. Fine. Stop talking. Oh, I'm going to be nice. 10 through 28 even. That's it. Do Wednesday. IXL do Friday. Quiz Friday. And then it's spring break.
Yay. I won't be here Friday.